Okay, so this video is going to help us finish up section 5.6. We're going to add and subtract radicals, as you can see from this opening slide. Then we need to do a little bit more with multiplication and division, which we started yesterday. So the only real rule you need to know here is that you can only combine like radicals, similar to like terms. So if the radicands, which are these guys in here, if they're not the same, you can't add them. So you may be thinking we can't do this problem, but what you need to think about is that we can actually simplify these 12, 27, and 48. So if I start to do that, and I'll write this out sort of as a reminder here. So I could write this as 2. I'm looking for perfect squares that go into these numbers. So we can write that as 4 times 3. I'll write this as 9 times 3. We're looking for the biggest perfect square that goes in. So 4 goes into 48, but 16 is bigger, and that also goes in. So if I keep going here, I have a 2. When I pull out the 4, that becomes a 2. I keep my root 3. Then I have 3 times 3 root 3 and 2 times 4 root 3. So that's 4 root 3 minus 9 root 3 plus 8 root 3. Now they're all root 3's, so they're all like radicals, so we can just combine the coefficients. 4 minus 9 is negative 5. Plus 8 is 3, so our final answer here is 3 root 3. So that's how you add and subtract. You'll see a couple on that worksheet and a couple in the review sheet when we review for the quiz next week. Going back to multiplication, and this is a little more complex than what we've seen, the biggest thing to notice here is that even though this looks pretty complicated, this is one term, one term, one term, and one term. We have a binomial times a binomial, so we're just going to FOIL this thing. So I'm going to start with this, and that expression gives me 6 root 5. Multiply the insides, multiply the outsides. When I do my outsides, I'm going to get plus 3 root 15. When I do the insides, I'm going to get minus 4 root 3. And then when I do the last, when I multiply the coefficients, I get negative 2. But when I multiply root 3 times root 3, I get 3. So I can simplify that, and that's just going to become minus 6 instead. I check for like radicals. 5, 15, and 3 are all different. So this is actually my final answer, this long expression with 4 terms here. So that's all we can do. The special relationship between the binomials and b, which we'll talk about now, is that the first numbers are the same. The second numbers are kind of the same. The only thing that's different is the operation in the middle. So if we sort of think of those both as positive 6's, and this is subtraction and this is addition, we'll see what happens when we FOIL this, and that's going to be important when we go back to division. So I start with my firsts. 5 times 5 is 25. I'm multiplying that by root 3 times root 3, which is 3. Then when I do my outsides, that's going to give me plus 30 root 3. My insides gives me minus 30 root 3. And then my last gives me a minus 36. So what we really like about these, and they're called conjugates, you'll see it on the next slide, but it's spelled like this. So these are conjugates of each other when these middle signs are different. The key here is that every single time you multiply conjugates, these middle terms are going to cancel out. Every single time. And now what we're left with is 75, right? 25 times 3 minus 36, so my answer here is just 39. And the key here, we're moving back into division on the next slide. We talked about the need to get rid of radicals in the denominator. And what we're noticing is that when we multiply some expression, radical expression, by its conjugate, again, we're just changing this middle sign here, it gets rid of the radicals and our answer is just a number. So we'll keep that in mind as we go on to some more complicated division problems. Okay, so let's get back into division. What we're noticing right away is that our denominator is a binomial, which we haven't seen. Do not write this down. This is not going to be correct, but let me just show you. A lot of people's gut instinct is to say, oh, well, when I see a root 3 in the denominator, I multiply by root 3 over root 3, and that's going to solve my problems. However, in this case, you'd have to distribute on the bottom. So while the root 3 times root 3 is going to give us a plus 3 over here, we still have 5 root 3. So we didn't really get rid of the radical, so that's actually not going to work. Okay, so let's get rid of some of this. I'm going to get rid of all that stuff I just did, and we need to use another strategy. We're going to use the conjugate. So what we just saw was that if I take this down here and I multiply this by the conjugate, the first term and the second term stay exactly the same. We change the operation in the middle. So I know that if I multiply this expression, 5 plus root 3 times its conjugate, I'm just going to get a number. And I'll prove that to you, but that's what we figured out on the last slide. Since we always need to multiply by 1, I'm also going to multiply the top by 5 root 3. Let's see what happens with that. So on the top, let's get that out of the way. 1 times 5 is 5. Then I'm going to have minus root 3. Then I'm going to have minus 5 root 3. And then my last are going to give me a plus 3. So we'll leave that for now, and we'll clean that up a little bit later. On the bottom, let's see our conjugate at work here. So 5 times 5 is 25. My outside terms is minus 5 root 3. My inside terms is plus 5 root 3. And then my last is going to be minus 3. And again, with conjugates, every single time, these middle terms are going to cancel. So let's see what I have here. Up top, I have a couple like radicals I can combine right here. So I have negative 6 root 3. And it doesn't matter the order in which you write these. But negative 6 root 3, my actual numbers, the integers there, give me a plus 8. Again, you could write that 8 minus 6 root 3. That's totally fine. And then on the bottom, I end up with a 22. Okay, so our mission was to get rid of the radical in the denominator, and we did. The one last step here, so if this is a 6-point problem, you've just earned yourself 5 points. In order to get your last point, all three of these numbers, so the coefficient on the radical, the 8 and the 22 have a common factor. So if all three of them work, so if this 8's a 7, where it doesn't work with just 6 and 22, it has to be all three. So all three of those have a common factor. So I would have to write this as negative 3 root 3 plus 4 over 11. That is fully simplified, and that's going to be my final answer. So again, my big concern right now is that you understand multiplying by the conjugate, that the middle terms cancel, and how to get to here. But we do need to take one last step when all of those numbers have a common factor. I divided everything by 2. I don't touch the root 3. That stays just like it is. And that's it. So you should be able to work on the second half of that worksheet today. When I'm back on Monday, we'll review for your quiz and get everything tied up. I can answer any questions. But work together today and do the best you can to work through this stuff.